We use computers literally every single day. They're smart, they're fast, they're essential. But have you ever stopped and just wondered how they actually work? Not the complicated code or the chips, but the basic idea. Well, today we're going to pull back the curtain and break it all down. Let's jump in.
And yeah, that is a huge question, right? But what if I told you the answer is actually surprisingly simple? It turns out that every single computer, from the one in your phone to a massive supercomputer, runs on the exact same, very basic principle. And once you see it, I promise, you'll start noticing it everywhere. Okay, so first things first, let's kind of reframe how we think about computers. Because at their absolute core, they aren't really thinking at all. They're just machines. Machines that are unbelievably good at listening to and following the instructions we give them.
And this definition right here, it's pretty much the whole game. An electronic device is simply a machine that processes information based on instructions. That's it. It's not some kind of magic, it's just a machine built from the ground up to follow orders, all powered by a little bit of electricity.
And if you look around, these kinds of devices are, well, they're everywhere. Just think about your oven for a second. You tell it, bake at 350 for 10 minutes. And what does it do? It follows those instructions perfectly. Your phone, your washing machine, even your game console, they're all just sitting there waiting for your command. A computer is exactly the same. It just knows how to follow a much, much bigger set of instructions.
So if a computer is really just following instructions, what does that process even look like? Well, that brings us to the real secret sauce, the core idea behind how every single computer works. It's a simple little 3-step cycle. This right here is the input, process, output cycle, or IPO for short. This is the hidden engine that drives everything your computer does. It's so simple. First, you give it an input, some kind of data or a command. Then it processes that information. And finally, it gives you an output, the result. Input, process, output. Over and over and over again. Now, I know what you're thinking. That sounds all technical and computery, right? But the crazy thing is, you do this all the time in your daily life, probably without even realizing it. Let me show you with a super simple, everyday example.
All right, let's talk about making a sandwich. The input, that's all your raw ingredients, right? The bread, the veggies, the butter, the ketchup. This is the raw data you're starting out with. Next up is the process. This is where the action happens. You're slicing things, you're spreading the butter, you're putting it all together. You are actively transforming those raw ingredients into something brand new. And what do you get at the end of all that? The output, a delicious sandwich ready to go. See? You took an input, you processed it, and you got a real, tangible result. That's the IPO cycle in action. Okay, a sandwich is simple enough. But how on earth does that same idea power the incredibly complex device that's on your desk or sitting in your pocket? Well, let's map it out. So let's really break this down. Your keyboard and your mouse, those are input devices. You use them to type a math problem or click on a video. The process, that happens deep inside the computer's brain. It's called the CPU. That's what does the math or goes and finds that video file. And the output? Well, that pops up right on your monitor, showing you the answer or playing the video. Every single thing you do on a computer follows this exact same path. It's that simple. All right, so now we know how they work. Let's get into something a little more fun. What actually makes them so different from us? How do our abilities really stack up against a machine's? It's really a story of trade-offs. We humans, we can think, we can reason, we can make our own decisions. A computer, it can't do any of that stuff. It's totally clueless on its own. But it is lightning fast. It never ever gets tired or bored. It can store a mind-boggling amount of information and never forget a single bit. And as long as our instructions are good, it doesn't make mistakes. It's got these incredible strengths, but they all come from just one thing, being really, really good at following our orders.
Now, all that power makes computers an absolutely amazing tool. But like any powerful tool, they're kind of a double-edged sword. They come with some incredible advantages and some pretty serious disadvantages too. I mean, the advantages are pretty obvious, right? First off, you've got speed. We're talking about solving problems in seconds that would take a human a whole lifetime. Then there's storage, holding everything from our family photos to entire global libraries. And versatility. You can write a story, chat with a friend, pay your bills, and learn a new language all on the very same device. And it does it all with perfect accuracy every single time. But, of course, there's always a flip side. All that time staring at a screen can lead to real health issues. They're completely dependent on electricity. No power, no computer. Our precious information is vulnerable to things like viruses and data loss. In a world where everything's connected, security is a massive concern, with our accounts and our passwords always at risk. So, at the end of the day, it all comes back to that simple little loop. Input, process, output. It's the engine that powers our entire modern world, creating tools that are just unbelievably complex. But still, these machines can't think for themselves. They're just sitting there waiting for their next instruction from us. And as they get more and more powerful, the real question becomes,